Hi, everybody. Thank you for attending this session. This session is called Lightning Component Communication with Twilio and Socket.io. My name is Jonathan Baltz. I work for a company in Chicago called Upright Law. We're an interactive law firm that focuses on helping people that don't have easy access to lawyers. And I'm also a Salesforce MVP. So the objectives of this session today is to describe the event-driven architecture of Lightning components, as well as demonstrate the communication between Lightning components and an external application, an external node.js application. So let's get into the event-driven architecture of Lightning components. So one great thing about the events in Lightning components is that it's asynchronous, meaning that you can fire an event and the application is it's non-blocking, so the application will keep running while the event is being handled on the other side. Another good thing about it is that you can use events in either a small scale or large scale applications. It doesn't matter the size of the application. Events will work regardless of how big or small the application is. One drawback of the event-driven architecture is that it's difficult to maintain a process of a process that you need to depend on one event occurring after another, since events within an application are decoupled, so you can't depend on one event firing if you want to time it correctly. So think of it as how you work with triggers. You can't depend on one trigger working before another trigger, so you don't want to have certain code depend on a trigger firing before or after another trigger. So in order to use events, you might want to plan ahead as much as possible. Because I know, saying plan ahead to developers is very difficult to say because you can never really plan ahead that far in advance. So events in Lightning components it's a separate Lightning resource. So when you do create it, it's separate from a component or an application when you're creating a new resource for a Lightning component. There are two types, a component and an application type events. Component events are ones that you can actually use within the same component. So say you want to use a single event multiple times in one component. The best way to do that is have a component type event and rename it, or sort of signify that it's named differently within the component, and then have it handled separately from the different other, separately from the other similar or identical type events. Whereas an application event can be created in one component and then handled in any other component or any other component within the application itself. So as far as the architecture of events, you'll have one event or in one component, you'll register the events, and in a separate component, you'll handle the event. And within the controller, you'll fire the event where it's registered and then handle or process a certain function in the component where it's handled. And I'll show you the code here. For example, here is the code for an event. An event, this is an application type event. So you'll see up here, it's designated as application event. And the event itself can have attributes, as mentioned, or is listed here, sort of like a component itself can have event attributes. And then you'll see at the top of here, I have a comment. So if you notice in this event, in the code, in the markup here, the name of the event is not mentioned anywhere within the markup itself. So in order to keep track of the events, where it's registered, where it's handled, I like to have a header that has the name of the event itself, where it's registered, and where it's handled, just so you can keep organized. So, because one of the things about creating a Lightning component application is that you're going to have a lot of these events. In order to keep track of them, you want to have some way of knowing where certain events are registered and where they're handled so that you can actually follow the code and know where to figure out how to debug certain things. So here's the code for registering an event. You'll just have the name and then the type, which is just the name of the event. And then in the controller itself, you'll set the parameters and then have a fire method at the end, the last line, to fire the event. And then to handle the event, you'll have possibly a separate component, say which event it is you're handling, and then what function in the controller that you want to fire when this, what method you want to process when this event is fired somewhere else in the application. And then here's the code here. You might want to, in the event, get the parameters that were set in the event, and then process the event, or process the code however you want to process it. So when the application I'm going to demo today, like I mentioned, I work for a law firm, and the main function of this application was to make phone calls. We wanted to use Twilio, and since a lot of the components functionality is written in JavaScript, we wanted to use the Twilio client JavaScript library to make phone calls. The problem was that the content delivery security issue where you can't make callouts to get JavaScript libraries, so we hit a sort of a roadblock there. So with that roadblock, we had two different options. One option was to use Lightning Out, which was brand new, so it's very exciting, but also a drawback. This is a Samsung Note 7, so new is exciting, but new is also very dangerous. So also there's a lack of documentation as far as how to use Lightning Out. The code that we actually did use was a repository on GitHub from Skip Sauls, and it more or less goes through how to use Lightning Out, but doesn't go into the great details of how exactly to use it. Or we could have built an external application on Heroku. There's endless languages and endless platforms, so not endless. But the problem was that we already were in the middle of building this application, and we would have lost a lot of the development time from building the Lightning component application that we already spent. So we found a solution, and the solution was build an external application in Node on Heroku using Lightning Out. The problem was that the events that we wanted to fire in the Lightning component were being fired from the Node application. So the solution was that you can actually have external events be fired in external applications, but this is actually the limit of, or this is actually all of the documentation there was available on how to fire events from non-Lightning code. This is all there was, and so we had to figure out how to use this information to fire events outside of a Lightning application. So the solution we did was we used Socket.io. And Socket.io is a real-time JavaScript library that enables bi-directional communication between web clients and a server. And so within the application, the Node application would fire or emit certain events, and then our page that's hosting the Lightning Out portion of code would actually, the Socket.io would emit events, and then by receiving those Socket.io events, the page that's hosting the Lightning Out code would actually fire the Lightning event. So I'll show you the code in that later once we get into the demo, which is right now. So I'm going to switch over to the application. So here's the Node application, and I'm going to log in using the force.js or the force.js library. And so allow it. And start a connection. And so right now it's going to ask for which phone number I want to use as the attorney. So in this example, I'm the attorney, and I want to search for partner intro calls. And I'm going to start calling. And so this is going to bring up different people that I need to make phone calls to. So I'm going to dial this person. And we're going to go through 2 examples here before I start showing the code. Okay?
This is Upright Law. Your attorney is looking to discuss your case. Please press 1 to be connected immediately. If you can't talk now, simply hang up. The attorney will attempt to follow up later. If you'd like to decline all future follow-ups from your attorney,
I'm going to press 9 to stop all future calls.
You'll no longer receive automated calls from Upright Law. Have a great day.
So now we'll move on to the second call. And so it's going to call me again. There it is. And we'll answer this one.
Hi, this is Upright Law. Your attorney is looking to discuss your case.
So the first example, I press 9 to stop all calls. And the second call,
your attorney will attempt to
I'm going to press 1.
If you'd like to decline all future.
Which brings up which actually will call the attorney phone, which I'm not going to answer. I'm going to actually act as if.
Hello, you've reached the voicemail.
Okay.
I'm not available
That's
to take your call right now, so please leave a message, and I'll get back to you as soon as possible. Thank you.
I'm going to end that call. Okay. So the example was supposed to be that it ignored the call. So the attorney ignored the call, which would actually stop all calling. And so the attorney is, if it works out that the attorney left from their desk or another phone call came in while the attorney was working through this call list, that would actually stop all the phone calls from calling and stop the application from working. So for the first example, I'm going to show the code. So right here is from lines 20 to 51. This is the code that we need to set up to actually add Lightning out or add the Lightning component to our code. And then within the call.js application is where we actually made the connection to the JavaScript client library from Twilio and actually made calls here. So what would happen here is that when a call would actually be made, in line 44, you'll have the line that says emit the call attempt event, and then go back to the page that hosts the page, the page that hosts the Lightning out component, and call attempted. Here's the call attempted socket receiver, and it would actually fire off this call attempted event for the Lightning component. And if you look at, so this is right now, this is in the node application, and I'm going to move into the Lightning component, which is over here. And so if you go into, I think it's called call attempted events. So here's the call attempted event. And so it says that the event is registered in the node application and then handled in the PPC container. Going to the PPC container, it's handled by the call attempted event increment call attempts. So I would go into the controller, the JavaScript controller, and increment call attempts. So in here, it's all this code over here is making sure that when we actually connect to the node application, we actually send the session ID for the attorney when they're logged into Salesforce, and then make sure that the event is sending back that same session ID to make sure there's no cross connections between other attorneys who are using the same application, perhaps in-house or outside of the house, and so that the same attorney that's using that node application is the same attorney that's receiving this node event that's fired that's receiving the event that's fired from the node application. So in the helper, you'll see that it's the update. This helper method is here, and I can go into the container, and all it's doing here is actually creating a activity within the application to update the session or and the call that was made to that client. So that occurs for every call that's made. The other thing that happened, so we had two calls that we made. One was where the client decided to decline all ongoing calls. And so I believe that person's name was Sean something. So I can go to Sean Forbes. And if you go into his contact detail, you'll see it right here, the DNC Auto-Dialer. So they were set to, by pressing 9, they were set to DNC. How that's occurring is in the actual Node JavaScript code, where if I find it here, so right here it's the code under lines 50 at the top here, lines 50 to 61, is where it'll play the client answers. It'll play the message that we heard, and then wait for the client to press either a 1 or a 9. If they press 1, it will connect them to the attorney. But if it presses 9, it'll play a message saying that you'll no longer be called by the attorney or by our company, as well as update their contact record with the DNC information. So it says, here it says, if 9 is pressed, is process do not call submission, as well as, right here, process update contact. First, let's go to process update contact. So the code's all the way at the bottom. Process update contact right here. And so through the enforce library, what we're doing here is we're finding the contact that was just called, and we are going to set their DNC checkbox field to true. So we just saw that in the actual node application, or in Salesforce. And you'll see that at 1:56, this is Central Time, it was updated with the DNC Auto-Dialer. The other situation that happened, so that is the updating the contact. The other thing that occurs is process do not call submission. And so what happens here is we play an audio snippet that says, you'll no longer be called by our company, thank you for your time, and then hang up. So the other example that we had was that the attorney was called instead. So what happens when the person does get called is that, let's scroll to the top of the code. So that is, press 1. So right here, app session. So it's going to get the app session ID that we sent and then emit dial attorney, which is another example of creating these socket events, going back to the index page, and dial attorney. So what this is going to do is that it fires off the client pressed 1 event, which is here. And so what this is so handled by a container. Go to the container. Client pressed 1 is down here. Oh, this is that component. So let me go to. I have occurred. So show approval comments. So what this is doing is that it's just showing that when the client pressed 1, that these fields right here, which is a separate component, will be showed so that the attorney, while they're on the call and while they're talking to this client, could take notes and then approve or reject or follow up with this client. And so that is the demo. I'm going to return to the JavaScript, or to the slideshow. So in summary, what we just saw is that Lightning Components uses an event-driven architecture. Events are generated by user interactions or non-interactive actions. And so when an event fires, the function that's in the handler will be processed. And there are two different types of events. WebSockets, Socket.io is the library that we use, used for bidirectional communication between server and a client. And using Node, you have your server on in the application so that the events can be processed by both the application and managed by the application. And so the external application sends the message and it's received by the application itself and then fires off the component event by receiving that message. So the libraries that I used were Enforce to update Salesforce, Force.js to authenticate within the Java or the Node application, Socket.io, and then I have a repository, and I haven't put this code up in the repository yet, so it will be up, and a link will be on the session notes. So that is it. Thank you very much. If you have any questions, I'll be available. So thank you.